Hey, hi everyone. I hope everyone is doing well. So in today's video, we are going to discuss about one of the most important rounds in the product management interview, and it's going to discuss on very open-ended questions such as design Google Drive for me, or design a feed system, or how do you actually design a rate limiter, how do you actually design Google Photos, so on and so forth, right? So it's an important, probably the most important, I would say, round when it comes to product management interviews, because it shows how you actually think about systems. It also tells the depth, uh, about how well you can actually connect the dots. And for companies like uh, Meta, Amazon, Google, um, Microsoft, I think PM rounds will have at least a discussion on this. I have personally interviewed with Microsoft, went till like the final round, didn't hear back. I was working with VMware, so that time I think there were definitely discussions on this. A startup that I work with also actually emphasized and had a very, a detailed discussion on this in one of the round. And then I think other companies where I have interviewed, or at least gotten, I think, information from people working there, is that this is a must do well round. So without further, delay, I'll just start with, so today we are going to discuss about how do you actually design a Google Drive. This will be a straightforward, open-ended question for you. And how do you go about it, right? So I think what I have done to help, I think, is that I have broken down, I think, all the parts that you need to focus on while answering the question, and make it like a two-way conversation, instead of you know appearing as it's like a memorization of some sort of a framework, right? So start with, I think, the high level design. And when you say I want to design a Google Drive, right, what is it that the user should be able to do, right? The user should be able to uh, do the following function, right? They should be able to update, delete, and edit file. They should, if they have delete, they should be able to retrieve temporary deleted files. Files should have synchronization. Files should be able to be shared with your friends, families, users, right? I should be able to view different versions of the file, right? Looking at this essential, flow for a high level design, you should be able to talk about, on the client side, obviously you have the mobile app, web apps, right? And the client server, right, that is probably hosting all of this. And then you have, your metadata sync servers and interaction servers, that are pushing the data to your cloud storage and meta storage. This is without getting into the details, so that it shows that you have some clarity, right? We are going to obviously get into the details of this, but to start the conversation, you can always rely on these kind of flows, right? Now, coming to the low level design, right? The low level designs are usually built from the technical perspective, like the technical capabilities that the system should have, right? So the system definitely needs to be highly available, right? 99.9999 should be expected. You can look at the numbers in any standard availability table, and you can probably take a call based on that. But I think this is what it would be if you have to make your system available 24/7, 365 days a year throughout, right? Highly reliable means, obviously, when you're doing transactions, for example, if you're uploading files, right, there should be no file losses, so your system has to be reliable. So it should be able to support large files, without your system going into pause or breaking down, right? So, and then back it up, I think it should obviously have a great context on the asset properties, right? So uh, the system should obviously support either a full upload or a full failure. That is what is meant by atomic in this context. The system should also be able to support versions on different devices and servers, right? So if I am, for example, looking at, let's say, an edited version of Google Doc, and if I access it through my computer or through my phone, I should not see different versions, right? I should be seeing the same version. um, Also, I think transactions need to be done simultaneously. So for example, if you are sharing a file with a user, right, and that same file, uh, maybe you're doing some sort of collaborative writing, and then you should be able to do transactions on that file simultaneously, right? And then of course durability comes because retrieval of the file and the information inside the file, I think that and all should be like, very easily available, right? So I hope you're clear with the high level and the low level designs. I think one of the crucial parts of a system design is to also get a perspective of the scale, right? How do you actually estimate the scale? So scales are basically estimated, in uh, crunching some, like I would say, back of the envelope calculation, do some number crunching, and then come up with some, like, estimate. So here, for example, right, uh, you can talk about, I think, the daily active users. Again, there's no right or wrong answer to it. It's just the assumptions that have gone into it, and how do you actually think about it, right? So you definitely need to think about the overall users. You need to think about the daily active users, right? And how much free space are you going to provide, right? Because that will define what should be a storage server's capacity, right? And then make some assumptions about, let's say, the average uploads and the downloads that the user is going to do, and probably attach some approximate reference of the file size, right? So keep, I think, these three or four things in mind, and that will help you in pretty much any user estimate question. You need to know obviously the total size, right? Which is, and so in our case, it is 50 million users. We're going with that assumption. We are assuming that we have 10 million daily active users, right? And we are going to provide 10 GB free space, right? So coming to the calculations on how much storage would you need on a daily basis as well as an overall basis. So 10 million into 10 GB, 100 petabytes, and then 50 million into 10 GB, right? 500 petabytes, right? Uh, let's also go with the assumption that you are going to upload two files per user. You're allowing two files to be uploaded per user on a daily basis, and those file size are like half MB, right? So what do you mean by that is that, uh, so this calculation is going to be useful. I'm going to explain like why is this actually, like, useful. So essentially two uploads daily, right, of 10 million users, and then you do the calculation by, the obviously the number of whatever seconds and into the number of hours, right? You get some number like this is 10 million, and then you divide it by this is the queries per second that your system basically needs to support. And where does this come into picture? It comes into picture when you're actually allowing API services to be invoked. Like, what is the peak or what is the average uh, number that of queries that those API services will be able to support, right? So this is in context to that, correct? These numbers are in context to the storage, 100 petabytes and 500 petabytes, right? That is in context with the storage, right? Now, having done, I think, these user estimations and the high level design and the low level design, let's switch on to the data models, right? And when I mean by data models is that how is your actual storage, how is your metadata storage, like, going to look like. So typically, I think for Google, or for any storage service, uh, you will need, I think, two different kind of storages. One is where you're actually storing the files, and the other one would be metadata storage, right? Why are metadata storage needed? Because you need to upload and download, I would say, slices of file. So it's not possible that every time a person is requesting a 10 MB file, on which there might have been some change, you are going to, like, download the entire 10 MB file, right? So how metadata actually helps is that you just keep the indexes of the file, right? Which is like slices, and typically use hash algorithms to understand what are the changes that have happened in those slices, right? And where are those changes actually going to be stored, correct? So a typical example, like let's say you have a 50 MB file and it is sliced into 10 parts. uh, you made up one change on that file. Well, let's say the slice 4 is the change. Now when that update is going to happen, right, let's say this is an update event, right? So what will happen is that you already had your 50 MB file with all S1 S10s already stored in the, like, your Azure, GCP, or whatever the cloud storage is. So instead of basically updating the entire 50 megabyte file, because that will be a very heavy operation, right, on the right side, what you're doing is just looking at that chunk of change that has happened, S4 in this case, and then you just update that file, right? So that is where metadata is like super super useful. The actual obviously storage database, right? How is that going to look like? There can be a parent-child tree, like, structure that you must be familiar. Is there in pretty much all the open sources like Linux, Unix, where you have parent-child tree. Windows also has it, right? We can also like think about using NoSQL databases like MongoDB, Cassandra. I think the most important part here is that you should be obviously able to create folder structure and, like, have uh, the files inside it, in your parent structure. And then obviously you should also be able to store meta information, right, as the date, type, sizes, right? There should be capability of nested folder deletions, right? So if I'm deleting a folder, for example, and if it has like 10 folders, subfolders under it, if I'm doing a deletion, then it should, of the main parent folder, right, it should delete all the, like, under subfolders as well, right? I shouldn't have to go about and find out each folder and then delete each one by one, right? And then obviously search, right? Because I can't, uh, if I am storing, let's say, 100 documents, I should be able to easily search it, right? um, I think, uh, I'm just taking an example of MongoDB, wherein you have all of these parameters configurable, right? So when I said, like, for example, creation of new folder, information on meta, search, nested folder deletion, there are like parameters that you can look at, right? This is very technical. I wouldn't expect people to like remember all of this, but clearly talking about MongoDB and saying that, okay, block and is folder and parent folder, ancestor folder, URL and search feature in MongoDB, shows that, okay, you have thought through the, you've thought through, like, I think, the requirements of a DB. We'll also see in the later stages when we cover the system components, a very important part of why like NoSQL databases are important, right? So we are done with the four parts: the high level design, the low level design. We covered the user estimates. We did the data models, and now coming to the APIs, right? When you're designing the APIs, right, what do you have to think about? So I think typically no one is expecting you to write the APIs in the interview. Uh, if you do, get into this discussion, it's primarily around understanding what are the different ways in which obviously these functions that you will create, right, or like systems that you will create will actually interact, right? That is the whole purpose, right? So APIs, for example, for download, right? Let's say when I'm downloading, what do you mean by that, and what kind of parameters I should be aware of from the user perspective, right? So I should be aware of the authorization parameters, file details, user details, right? An authorization parameter could mean like token, right? So let's say, for example, you're signing on, you have your email IDs and password, that could probably go in as a token. The machine IP, whatnot, right? The file details, right? ID, name, version, right? And user details, ID and name, right? Similar thing happens when you're doing edit, delete, and upload. So in edit also you definitely have to pass the authorization string, right? You also have to pass what is the string itself that you're, like, editing it with. So if you had like a document, right, say, right, a paragraph, and a document might have 10 paragraphs, you decided to delete two or three paragraphs, right? That is the string detail that is needed, right? And on which file obviously you're doing it, plus the user for which you are, like, are doing it, right? uh, Delete, again, same. If you're deleting the file, uploads, pretty much the same. The one thing that I think most of the videos or like in the books will not cover would be the restore APIs. So restore APIs, I think, are probably, I would say, somewhat related to delete functionality. But in delete functionality, what happens is that you preserve the file for some number of days, right? Probably 30 days, 60 days, you can decide it, right? Restore functionality basically allows you to restore that file back into its original space, into whatever, like the hierarchy you had, right? So it should definitely have authorization, it should have string details, it should have file user detail and trash parameter. So trash parameters would be something like whether the file exists or not flag, right? So if you passed the 60-day limitation, right, then the file is not going to exist, right? Maybe you have deleted multiple versions of the file, which version of the file do you want to like restore, right? It's kind of a like sub soft delete, if you have to put it that way. But it is essentially the most important of all of these APIs, because uh, users, for example, now with Google doing its pricing, right, where you have limited storage, right? uh, if you cross, let's say, 50 GB or like 20 GB of free storage, right, you will have to delete those files, right, when the storage is exceeding the limits, right? So in that case, I think maybe temporarily you might make a move and decide to download some files offline, and then you still decide to restore the files that you had deleted 30 days back, right? So from that perspective, it's kind of like important. So APIs, I hope it's clear. Never get into like bogged down by like what is the exact syntax of APIs, and like what. I think just understand the functionality and the use case around like the APIs, right? So I hope that is clear. And now coming finally to the most important part of this discussion, which is the system components. Don't be scared looking at this diagram. I will explain to you all the components that are present here. So I think when you start with and this is like probably the final stage of your interview. You have done the high level design, you have done the low level design, you have done the estimates, you've done the data models, APIs, and like the last part is bringing pretty much a big system that is interacting with the components together, right? So you have your client trigger, right? It will have some, let's say, capabilities, right? What are those? We'll discuss that. You have a NoSQL database where you have your folders with file, right? You have your cloud storage, you have a messaging queue, synchronization service, caches, API service, load balancer, and app server, right? Now, I think this can be overwhelming without a doubt, unless you start connecting the dots, correct? So let's assume that your client uh, I mean, your client basically means like a mobile or whatever web app, right? It needs to have certain functionality, right? So what functionality, right? It should have a notifier capability, which means that when files are uploaded, I would probably call it like UD, updated, deleted, and edited. Uh, there is a notification that it should be able to generate for the other systems, right? Index service, obviously, because we want to maintain whatever files you have stored, right, to some index. Slicing service, we discussed about it, right, in the in the low level design also, and also in the data models, right, where we are saying the slicing right component. And then also the internal user database and the internal meta database, right? Those are like the important like components of client trigger. We'll talk about like how these actually make sense. You also definitely need to have a message queue. There will be a global request queue, right? Because all the clients, for example, Samuel, you are a user, your friend is a user, XYZ, all are users, right? They're just pushing changes right onto their file, right? So any server, right, will obviously not be able to handle simultaneously, right? And it will not do justice also if someone who has requested the changes, let's say 1 hour back, is still asked to be waiting in the queue, right? That's why you need a messaging queue. We discussed it in details, right? The messaging queues in one of our videos, right? So go back and look at it if you want more details. But message queues are here are like doing two things. One is that whatever like requests are generated from the client, those are being like when they're performing, let's say, UD operations, they're sending all the relevant information to the sync service, right? The synchronization service. And the sync service is needed because you want to keep your updated databases updated, which is your metadata, and also let's say your cloud storage, correct? Uh, the client response queue, right? which is where this is pushing back the updated information into the client, right? So what does it mean? It means that, let's say, the metadata server updated the index, right, of a file because you inserted new information into your file, right? Then that information needs to flow back also, right? It needs to flow back to your, like, whatever phone app or whatever web app, right? So you need to know the latest whatever, right? Information about the file. Simple example: you update a file, right? You get a timestamp. The timestamp shows the last updated time, and it was the file was updated. You made some changes. Now the timestamp has to reflect that you made the change on so and so date. Correct? So that happens because the metadata server, once it actually makes the changes on the indexes, it pushes back, through the sync service and the message queue back to the client, right? So that is the whole, like, this flow that you have to understand. Synchronization services, okay, quite a few important points about the service. It is essentially used to update the metadata database, right, with all the latest changes. The example that I gave, right, you need to update the timestamp, right? It also broadcasts, like, to all the other services. Like cache is one service that is being, cache is like, okay, we'll come to like why it's used, but caches should also be aware of like what is the latest indexes, or like, the file structure, right, for example, or the file value itself, right? Values that need to be there, right? So it updates to the clients via the client response queue, and then also the sync service will update the local database with the metadb information. So here you see, for example, right, I do have the synchronization services pushing through message queue via this route, where I am also looking at the app service. Now the app service is going to push in the changes back through this route through API service, and then that is going to, like, change here. The change is going to sit in here, right? So synchronization services are helping you with the update on the local DB as well. With the meta. And one important concept here is around, what if your client is offline? What do you do then? Like, your client, for example, your phone might not be in a reachable area, right? Then what do you do? Then you have something called as long polling, where you, like, the client is offline, then you can use the long polling to update the data. Correct. And then finally coming to the cloud caches and other DBs, like all the databases that you can think of, right? Storing chunks of files for the user. Lot of frequently accessed files obviously will be handled through the cache, and then the API call services will be provided by a cloud provider. A metadata DB usually preferred, I would say, here, for example, right, or wherever you're putting the uh, meta information of your files, would be consisting primarily of NoSQL. Remember, I talked about it uh, in the high level design also, or sorry, the low level design also, where I mentioned that why, oh sorry, in the data, extremely sorry, why we need a NoSQL database. This is the reason why we need a NoSQL database. You have to have data consistency uh, throughout. Like a file that is sitting here and the same file sitting here, uh, obviously need to have consistency, right? Now, you can also argue that I can manage this through a SQL server, a SQL database. But the problem is that for that, you need to have some sort of a mechanism around the SQL database, which helps you not putting too much load on the SQL server, like, the SQL databases. Because uh, what will happen is that if you are putting too many read or write requests, right, unnecessarily, your SQL databases will be, like, overloaded. So what you're doing essentially is, you're saying that I am okay to go with, like, a distributed, kind of database, right, which is meta, which is, NoSQL databases, and then I am okay, to not, let's say, maybe invest in some kind of wrapper services, right? Typically, I think for SQL databases, you will have to invest in that, right? So, I hope this video was useful for you. Uh, I put in, like, the overall number of, let's say, the steps, right? So, when you go in an interview, please keep these things in mind: the high level design, the low level design, the user estimates, the data models, the APIs, and finally how it all comes together. Now remember that this is not the maybe most accurate um, system flow, but it shows that you are thinking about multiple systems, right, interacting together, right? So until we meet next time, feel free to leave comments, do subscribe to my channel. In the next video, I think I am definitely going to look at more system design concepts. uh, there have been requests by people to cover system design from a machine learning perspective. I'll have to think about it, and how to, because that is going to be even more complicated than your normal system design, because there is a different concept of machine learning that comes into picture, right? So feel free to reach out, you know through my booking link as well. If there are any questions, you can also connect with me on LinkedIn. I hope you found this useful, and until next time, take care.